All right, welcome everybody.
Thank you.
So today we're going to talk about Regex. This is a pretty kind of basic introduction to Regex. How many of you are familiar with Regex right now, would you say? On a fist of 1 to 5, how would you say you are? 0 being nothing. You're a 4? You think you're a 4, really?
I've been doing it 15 years.
Okay. Some beginners, I would say I'm a 3. Do you know anything about look-aheads?
Mm-hmm.
Okay, that's where I stop. Stop at look-aheads and look-behinds. Those are confusing to me. So this will be like the super basics of it. Yeah. If you're bored with it, feel free to correct me. Okay. Regex, also known as regular expressions. And someone else said it sometimes called Reg-E.
I was making a joke off of the X having a question mark after it.
Oh, a Regex joke.
Yeah.
I see what you did there.
That went over about as well as I was expecting.
How'd you yourself cheat?
What? Regex. I say Regex.
I say Regex.
Regex?
Regex, quite about it.
Regex, yeah. So, what it'll do is it'll allow us to search for text within text. We can do a lot more than that. This is my main use for it. Originally, I learned Regex to find and replace large sums of code in my code base. And now you don't have to do that as much. You can kind of have some tools that are a little bit easier, a little bit nicer, but I used to replace class names, like rewrite all the class names, come in and change everything. You find it in most programming languages, even if, I don't know if they actually support them out of the box, but even if they don't, there's always like a library for it, right? So it's portable across languages, similar to something like JSON would be, and it makes you feel like a champion. The reason I say that is because if you write a really good regex, you feel really good about it. Right, look-aheads? See, I never got that far, but if you get so it's a fun competition if you can't figure it out. I mean, it's not as fun if you go on Stack Overflow and just copy and paste it. You don't get that satisfaction. That doesn't count. But if you wrote it yourself, it feels real good. All right, so what makes up a regex? Well, we're going to be referring to it in JavaScript. There's slightly different ways to write it in other languages. In JavaScript, this is a regex literal. So it starts out with our slash right there, also known as slashies, according to Patrick. The next thing is our pattern. This is where we're doing most of our matching, all of the kind of dynamic characters that we want to match, whatever we're searching for. And then we'll have the end one, that's the end of the pattern. And finally, we have flags on the end. So flags are kind of like arguments to pass to it to say, in this case, we're using G, which means global, means I want to find all matches within here. The other one I use a lot is I for case insensitive. There's a few more, but those are the ones that I use the most. Another one's like multi-line in case you're searching across multiple lines. But again, I'm usually just searching on a smaller string. All right, so some examples. This is the bare bones example, just /ing/G, so we're saying it's global. And ing is going to look for the string ing in consecutive order, those 3 letters. So for example, some matches would be going, inkling, and singer. So it would also match things that are in the middle of a word. It doesn't matter if it's at the beginning or the end because we didn't specify where. We just said anywhere in there. It won't match something like pin. That's like in case you're thinking of each letter, it won't match each individual letter. It'll match them consecutively here by default. Same thing with gain. It has those 3 letters in it, but they're not in the right order, so it's not going to match it. And also capital painting, notice since I don't have the /I flag on there, it's not going to include case, or it's going to be case sensitive. So we're only looking for lowercase by default. That's searching for the string ing, matches anywhere in the string. Here's an example on a full sentence. So on the weekend, he would play bingo with friends. He also loved to dance and sing. So since we're using G, we're matching those two in there. Imagine if this was a one longer string and you were trying to match it on this whole string. Without the G flag there, it would only match the first one it finds. So a lot of the times I'm usually looking for all instances. I'm trying to like find and replace everything. But if you're just trying to find the first instance, you can drop off the G there. Any questions about what's going on in the intro so far? We're not too crazy yet. Okay. So the next one, .ing, and notice the dot is blue. That's because it's a special character. So the special character for this one is actually saying match any asterisk single character. I say any because it will be anything but a new line or like carriage returns, which to me is like anything but that. So still almost any. It's considered a special character. A dot means match any. So what it's going to match is match going, like OING, fixing, XING, and ping, like a capital P. Since it's matching any character, it doesn't care about case sensitivity. So it will match uppercase as well. And then down below, you can see some other examples of other special characters. We're going to look into a little bit of those as well. Here's an example on another sentence. On the weekend, he would play bingo with friends. He also loved to dance and sing. There's a lot of dance and singing in this. So in those ones, it matched the B and the S in addition. But it could be any kind of character. It could be a space. It could even be like dashes or those kinds of things. So just as long as it's not a new line, there's a lot of other characters that would be included. It could be a digit. All right, next one, backslash. So a backslash allows us to escape a special character. So maybe we actually wanted to match a period specifically. By default, since it's looking for any character, it's going to match anything. So that's like a common mistake that if you're trying to look at a file name or something, you might match any character. But if with the backslash, it's going to look specifically for the period to treat it as plain text. So for example, the img.png, it'll match the .png, and .png something else, it will still match the .png. Because we have the backslash, we're looking for the period only, so it won't match underscore png, and it won't match something else like jpng. An example of this one is filename.png is 256 kilobytes. All right, and then into digits now. So another special character that you use a lot is /d. That means a digit, and it refers to any single digit 0 to 9. So it's looking for one digit. There's other ones that we'll talk about in a second, but up here in the examples, you'll see we have 143 kilobytes, but notice only the 3 KB is selected because it's looking for a single digit. 0 kilobytes, it would select that whole string. Something like 5 kilobytes, it's not a real digit, it's just the word. And 10 space kilobytes won't match because there's a space in between it. It doesn't look for the space. It's just looking for a digit followed by KB. Some other kind of special backslash characters you can use, like usually there's a capitalized versions of it. So /D is any non-digit. It's usually the opposite of whatever it was. And you could do /W for any alphanumeric, which is A to Z or 0 to 9.
So /W would be any non?
It would be, yeah. So it would be the opposite, any non. And /S, any space, including if you're looking specifically for a new line or a tab, you can look for those as well. But /S would be like any white space. Sometimes, so if we had something like, well, let me ask you. If we wanted to match 10 space kilobyte, how would I update that regex to match it?
Say the match you're looking for again?
We're looking for the 10 space kilobyte.
Oh.
You want to match the whole thing?
Yeah. Well, no, I want to match, I guess, 0 space. If I wanted to capture that space as well, how would I do that?
/D, /D, /S, KB.
Yeah, that would capture the whole thing. Good point. I was just going for the quicker one, but yes. So the next one that we'll show, well, actually, here's another example. Filename.png is 256 kilobytes. 6 KB is just selected, but In reality, we probably want to select the whole number, so that's when we start using the plus. Now, the plus says it will match any one or more of the character that comes before it. So in this case, the character is a digit. So we're saying a digit, one or more of them. So that will match all sequative? Is that a word? Consecutive? I'm making up words just on the spot. So it'll be 143 kilobytes. So that would match all that, 0 kilobytes. But something to be a little careful of is if it's 1.5 kilobyte, the point doesn't count as a digit. So that would not be a match. It would match something, but not what we intended to match in this case. Or 10 KB, again, because the kilobytes is capitalized and we don't have our I flag on, it's not going to match that one. So you can also use an asterisk, which will match 0 or more. So if you wanted to say, like, the number is optional, or I want to grab all the consecutive numbers. Sequitive. What did I say? Sequitive.
Where's the asterisk go?
What was that?
Where's the asterisk go?
In place of like the plus. So if you plus or an asterisk, the difference is just plus will match 1 or more, asterisk will match 0 or more. All right, next one's $sign. So we got ing and the $sign on the end, and the $sign means to match the end of a string. So this, for example, with singing, it wouldn't match the first one, it would only match the one at the end of the string. And driving, it'll match the end of the string. Something like singer or bingo, those are in the middle of the strings, and they're not at the end, so it won't match it. A longer example of that is on the weekend, he would sing in a band while the crowd danced the swing. I had to make up some weird sentences to make these work. Yeah, but I already used sing so much. I wanted to switch it up, you know?
It's right there, though.
Oh, I see what you mean, yeah. So that it won't match that one. So it won't match the strings ending with punctuation. That was like if this ended with a period, because say this whole value is our string. If there was a period on the end of it, that wouldn't be the end of the string anymore. It would be one character from the end. So it wouldn't match that. But it won't match this one.
So it's really asking the last 3 letters in here.
Of the whole string, not just each word that it finds, yeah. So I did put that in there on purpose, yes. All right. And the next one is the caret. A caret matches the beginning of a string. So in this one we have caret and then out. And also notice I have my I flag on here. That's to show you that we're matching a capital out or outer or outside. Those would match. However, something like inside dash out wouldn't match because it's not the beginning of the string. And about wouldn't match because it's not the beginning of the string as well. So another example would be outside was a large patio with an outstanding dance floor. Notice it matched the first one, but not the second outstanding because it's not the first of the whole string, just the first of that word. If you wanted to grab like the first of every word, you could take the sentence, split it up on spaces, and then find it at the beginning of each word, but that's a different use case. The next one is or. So in or un is what this is saying, and it's got the global flag. It's a pipe. It will look for case insensitive matches if using the I flag. In this case, I'm not using it just for my example. So in blunder, it would match the UN. In find, it would match the IN. Doesn't have to have both. Again, it's an or. With a capital I or capital U, it's not matching those because of the case insensitivity. I did not include it on this one. Once inside, we danced under the disco lights. Can you see where this story's going?
It needs to love.
Yeah, it could. All right, JPEG. Back to Zach's funny joke in the beginning. You guys will be able to understand it after this slide, if you don't already. We'll go back and do it again later, okay? See if it lands better. So a question mark means match the previous character 0 or 1 times. So it's kind of a way for us to allow to say like, yeah, I'll match it if it's there, but if it's not, I don't really care. So examples, the biggest example that I always use this with is JPEG. I always would see it with this. For JP, it'll match JPG because the E is not present, so it doesn't care if it's not there, but it will also match JPEG. Because when you're uploading files, you know, it could be JPEG or JPG. They're both the same. And it wouldn't match something like JPENG. Don't get the question mark confused with like any character. That's a period, not the question mark. And if you wanted to get tricky, you could use an escape to match the real question mark. Not that tricky, but we already learned about the escape. So that would match something like Y, but it would not match something like who. All right, now into the brackets. So this is where things start getting more fun, where they're not like basic anymore. So brackets are holding a character set, and it allows us to match any of the individual characters. So like originally we had just /ing/, that will match the specific string ing. With this one, it's saying look for the character I, or the character N, or the character G. And it's going to do it globally because I have that flag on there. So it's still case sensitive without the I flag. It's only going to look for the lowercase here. So in gain, we'll match the G, the I, and the N. Doesn't matter if they're consecutive or not because it's looking for those individual letters. And in ginger, it would match all of those, and it would match multiple G's because the global flag is on. In pack, it wouldn't match anything because it doesn't have any of those characters. And golf, capital G, it wouldn't match because it's not the same case. If we wanted to match that, we would have to throw in the case insensitive.
Would it match if it's not one of those letters?
Yeah, it doesn't need to have all of them. Just looking for any one of those. Yeah. In this case, the twins could dance and sing. So it'll match I, N, even though they're next to each other here, that's not really relevant. It could swap the N and the I, and it would still work. But the N by itself, it will match that, and then the ING matches similar to how it did before. All right, now we can look into ranges. So dashes can be used to indicate ranges. So this says everything from A through C, and that would include A, B, C. I only went a few in, but usually people use this with like A to Z or A to capital Z if you wanted to do case specific. That's most common when people are looking to select like words or something like that. In this example, you'll see an able that grabs A and B, and in capital Aaron, it will grab the two A's at first because I have my case insensitive on here, so it will grab either one in this case.
Can you do any generic range? Can you do plus the dash?
I don't know how to get into those. I mean, I know A to Z and 0 through 9 are the common ones,
Yeah.
but I wonder, if in the character map, if you can say like start at the plus and go till the division sign or something like that, it probably would work like that.
You can. So it just follows basically the ASCII table.
That's
which
what, yeah.
is why you can't really do like lowercase a to capital Z because you're going to have a bunch of other characters in that.
In between them.
Yeah.
Yeah.
Because
The
they're not-
lowercase aren't back to back with the uppercase, or?
They're not. No. If you look at the ASCII table, there's some.
Well, who designed that?
Jim Askey.
Is that a real person? That's a cool name. So in this case, all you ever talk about is dancing and singing. The capital A, the lowercase a, the A's and B's, and the C's. It's going to match all of those because it's case insensitive and it's global. All right, and then finally in here, some flags. So we've seen them throughout the whole way, kind of using them here and there, but just to talk about the flags on the end, they come after the closing slash. It's a little weird at first because it looks like it's just something hanging right there. And you can have multiple flags, such as /GI. In this case, it could be IG or GI. The order doesn't matter, unless maybe you're using one of the other ones. I'm not sure, but just these two. It's not that important. So in pants, it'll match ANT. Antipasta, it'll match the capital A because they have the case insensitive. But it won't match something like can't because we're not accounting for that apostrophe in there. Even though we have ant, if we wanted to account for that, how would we say, like, include the apostrophe, it's there, but don't include it if it's not?
Do an apostrophe question mark?
Yes. The good old question marks. So that will match 0 or more. And faint, it's close, but it's not quite there.
So if you only had the I, it wouldn't search globally?
It wouldn't search globally. It would match the first one. Did I have one? Yes. So here, no. The I is case insensitive.
Right.
So it would still search globally because we have the G flag on there. But in this case, we're saying, I want pizza from Anthony's. So all capital A and T, that'll match because of the I flag. And then the second one will match because of the G flag and the I flag because it's multi-case. Okay. And from there, I was going to pull out some code. So that was just introduction to like, thank you, Zach, to like what we can do with regex. I was going to go into exploring a little bit about like the JavaScript methods in regex, or the regex methods in JavaScript, and like how you can use them and which ones are common and stuff. But before I go into that, what kind of questions do you have about the regex so far?
What does regular mean in regular expression?
I think it means not that hard to read.
But they are.
They can be, yeah. Regular as in like the basic stuff that I showed you today seems pretty regular. Like you could kind of, I don't know, it figures it makes sense. But when you start getting into things like, so the ones that I didn't talk about were the capturing groups. Those are really big things. That's more when you want to find and replace things. That's great for that. Also, I didn't show you the not selector, which is another thing. In the brackets, you can start with a caret at the beginning, and that will say match not these characters. That's a handy one to use. But you can get into a lot more crazy things with the look aheads and look behinds. And is there other ones that you use? Is there other things that I didn't show that you use commonly in regex?
I think that's most
Look
of it.
aheads?
Yeah, the look aheads and look behinds, like those are, I don't even know how those work. What is it saying? If this character is preceded by this or something like that?
Not followed by this character or followed by this character.
Yeah.
Like basic regular expressions will just go left to right, like character by character looking for the match. An extended regular expression can use context in front of it, which requires it like bringing the entire thing.
Yeah, that's where my mind starts getting boggled because you start going back and forth in the string. That's when it's time to go to Stack Overflow and search for something.
So they're called regular expressions because a regular language is a CS term. It's a formal language that can be expressed using a regular expression.
Boom.
That,
A regular language, yeah, that's what I said. It's regular text, right?
Nothing to do with coffee.
Nailed it.
No.
Um,
Coffee?
GD regular.
I don't know.
Ah, I see what you mean.
So are all the flags and selectors, are those all same between all languages? Is there any?
I think they should be, no?
No, they vary pretty widely.
Do they really?
Yeah.
That's confusing.
I think that the basic stuff is pretty well standardized at this point, but there's special features of all the different
Right. So I originally learned regex in PHP, and I remember they had like $sign for starts and ends, but I don't know if that meant a different kind of regex or something. I did it when I was a lot younger and more naive, so it worked, so I don't know.
Yeah.
But other languages, I have heard they've got like special kinds of additional things that you can do. Any other questions before I show you some hacking? All right. That's my animated tabs. I'm gonna search for Indian regex. If you want to play around with regex, there's tons of tools online to play with it that are super helpful. I don't even have one that I'm particularly fond of because they're all really good. You just click one and they all work. Usually they'll help you out with like coloring special characters and matching things. You can use find and replace. You can do all that kind of stuff. You could check different languages too if you wanted to do it, but I'm mostly using them in JavaScript. All right, so this MDN page is a great resource of information for regular expressions. In JavaScript, we have a few ways we can make some regular expressions. So what we saw before was is that big enough for you guys? The regex literal. That's just kind of like making an object or an array. Those are the ones that I use most of the time. There's another way you can do it. There's a reg expression constructor, and this one's handy if you want to pass in a value. Like maybe you're having the user search through text for something, and they're passing you the string they want to search for. You can use that plus with some of your own special characters to kind of build your own regex, and that will.
Is that a good idea to do?
It can be dangerous. Yes, it can be dangerous, but it is possible. And then let's see. There was an example in here somewhere. So you see, these are the few ways to set it. The literal, the new reg expression, you pass the pattern in, and then the flags come as the second argument. And then here's some of the flags. Global, we saw they call it ignore case. I thought it was case and sensitivity, but same idea. They also have multi-line in case you're trying to like match things across multiple lines. Unicode if you're looking for some Unicode stuff. I've never used the sticky. Match is only indicated from the last index. Let me look down here some more at some examples. So we talked a little bit about like some of the basic character items. The dot, there's the digits, the W's for any alphanumeric in the Latin alphabet. That's A to Z, capital A to Z, lowercase A to Z. Oh, it also includes underscores too. I didn't know that. 0 to 9. So a lot of times when you want to search for like underscores or dashes, you have to include those as well. It doesn't always include it by default. This will include the underscores though. And then again, the opposite would be, this would be saying like not, anything that's not in this set right here, this character set. Single lines matching the spaces. There's a lot of different spaces that it includes in there. Non-white space. You could do tabs, carriage returns, line feeds, a vertical tab. What's a vertical tab? I've never.
It's regular.
It's regular.
It's very regular.
Form feeds for the good old days. And then some more complex stuff. Another one that I didn't talk about in the slides is down here. So this is the character sets we looked at. We mentioned a little bit X or Y or Z, A through C. You can also do the not if you throw the caret in the beginning of that. The pipe. There's some more characters we talked about. Word boundaries. I've never really used those, but I haven't had to like parse through a language to try to figure out what's going on, but there's a lot of selectors like this that you can use to kind of read a document, I guess, and extract data from it or something. Regex is really handy too, if you're doing some kind of like data mining off of a website or something, you can pull values out and match them up.
Vertical tabs were from printers, like dot matrix printers. You enter in that character and it would make it skip a bunch of lines.
Oh, like a paragraph almost? Yeah. Okay. There's also the curly braces. Those were special characters. I didn't talk about them in the slides, but they give you the option to match a specific number of a character, a specific amount of occurrences of a character. So X with N. So if I said X was 0, it would match 0 where there is no X's. If I said 1, it would match where there's 1 X. 2, I can match with 2 X's. I can leave, there's a second argument to say like 2 through 5. If you wanted to do that, that would be N and M. If you just leave it off, it's going to say 2 through as many as you can find consecutively. And here's your look aheads and look behinds. Question. Matches X only if X is followed by Y. That's interesting.
E.
Yeah, that's interesting. Okay, so the methods. Where's the methods? Down here. Okay, so there's a few in here. The ones that I use the most are .test and I think .match. That's actually on like string, yeah, string prototypes. So some of the regular prototypes can take normal string values, or they can take regular expressions as well. You can actually use a regex on split too. That's something I learned during this. I didn't know you could do that. So if you wanted to like split on multiple values within a thing, I haven't needed to do that, but that's cool. Yeah. There's also exec for like execute. I don't use that one that much. Have you used that a lot?
I've never used that one.
It's kind of like you execute it, and then it finds the next thing, and then you can do something with it, and then you can call it again, and then you can find the next one. You can keep going through it like that, like in steps. Usually I'm doing like a find all, replace all kind of thing. So if you're just doing a basic, you just want to say, hey, is a string in there? You can do .test. That's the one that I use the most, because that's going to return Boolean, true or false, whether or not it matches, it's in there. And where's the string one? Oh. And there's also like, so on string, there's some methods. Replace, we'll take one. So you can do replace and choose a regex. And this is where you see there's parentheses in this one. The parentheses are the capturing groups. So it's looking for any of the alphanumeric characters, one or more. It's going to capture that in a group, and then we can pass that in here, and then we can replace it with the dollar signs. That's going to be the result of what it captured. So if we wanted to swap text from like one place to another or something like that, or just grab a part of something out of our whole selection, then we can do that as well. All right. Those are the main ones I wanted to show you in here too. Any new burning questions you have?
Do you know if they have named capturing groups in JavaScript's regex?
I don't think so. How would you write a name? Like, how would you name it? I think it's just numbers, because it comes out like this. It just gives you the
I know they
dollar
have it-
sign number.
They have it in other implementations. I've used it before. I don't know if I've ever used it in JavaScript.
I've never heard of people using JavaScript.
Yeah.
I've used the dollar sign number ones before.
Yeah. Sometimes if you've got something really complicated, it's nice for readability.
Yeah, if you're
Nice to
doing
kind
a
of see,
huge
like,
thing. So you can get some pretty crazy ones.
basically creating variables and referencing them later, so it makes it more readable to kind of see what you're working with instead of dollar numbers.
Yeah, if you start to get like 10 of those and you move one from somewhere, oh, that's such a pain.
Yeah.
What a terrible life. Okay, let's try to write a regex for an email. This is a common one that you'll have. I know there's a lot of different ways you can do it, but let's get pretty basic here. We just want to match a basic, let's say we want to match chad@mail.com. Oops. We're not accounting for all the other, I mean, you can count for multiple domain names and those kinds of things, but say I just want to match like the @ and the dot. I can use .test. Oh wait, actually .test is the other way around. So you write your regex followed by the string, you pass in the string. So first of all, I want to say match any character, let's say like A through Z. I'm going to do case insensitive. What will be the next thing that I want to write to check to see if this is an actual email address?
Did you not do just /W instead of A to Z?
I could. I like the A to Z's, but yeah. Is it a lowercase? Yeah. /dubs?
You should look for it. Yeah, over in that side.
Okay. Maybe I should.
When you want to repeat that, right? So you have any alphanumeric character, and then you want to repeat before the @ I think.
Oh. Repeat. Yeah. One or more?
You do plus.
Okay. Would you write them all inside here? I don't know.
So the brackets mean any of the inside things, right? So the flush should go outside of that. Slash W, is that right?
I don't think you need the brackets at all,
Really?
because you're not doing a
Oh,
character
yeah.
class.
Do you know how slash W works with like complex Unicode characters? So like Chinese or something?
In the docs, it said A to Z and 0 through 9, so I don't know if it would match those.
Especially
Maybe.
if it's going off of ASCII values, like,
Yeah.
I don't know if there's a UTF-8.
You might have, that's when you might have to get into like the Unicode flags. I never had to mess with those. Let's see. So if we remove the @ all right, it's breaking already. That's good. Let's see if I remove the dot. So again, I want a word plus 1 or more, and then how would I check for a dot? Slash dot.
Backslash.
And another word.
But that one's not W because you can't have numbers, right, after the dot as the letter.
Oh yeah.
Could you search for like com or net
I don't
or?
think so. Or at least you for sure can't start with a letter. I think you have to be like dot letter.
So the last one
Pretty sure that means are only letters.
Yeah.
Never.
Dot what?
Slash D. That last one should be slash D instead of slash
That's
W.
And you can't take.
No, we want to match.
numbers.
Oh yeah,
Oh,
a
sorry.
non-digit, but that would match in other characters that are not non-digits too.
Oh,
You could say, yeah, A through Z, right? A through Z, and like, I guess we'll take capitals too. A through. Oh, we already have. Yeah, I. A through Z plus. Is that going inside or outside?
Outside.
Okay. And then on the very end, there we go. All right, it's a match. And that's like a really basic one, but a real one that you find online is going to check for all kinds of domain name types and probably more stuff like where we don't have numbers. It doesn't start with a number after like the domain name. I guess that doesn't matter for the domain name, but for like the .com and stuff.
So the biggest problem with Regexes in my experience is that they're okay to write, but then once you look at them, they're totally impossible to parse.
Yeah.
Like bad code or something. Is there a way to get around that?
The best that I've seen is like it will ignore the new lines, so you can put things on new lines and then comment out to the right like what this is specifically looking for. But
You can do that in JavaScript.
I believe so.
Learning tools that let you like give it regex and it spells it out in like English. I'm looking for
There's
this.
tools that does that?
I know I was
Tools
asking
online.
earlier.
Is there?
Yeah.
They basically do that. I mean, if you go paste that regex in there, it's going to tell you what each of those things is doing and what it's capturing. And I mean, it's helpful, but they're still gnarly, like to read. Some really, really long ones that I've had before, I've broken into like multiple lines just to try to make it more readable. And I've definitely like had long strings on multiple lines with comments explaining like what each
Yeah,
step does.
that's the best I've seen like that you can do with
Yeah.
it, because otherwise it does get very confusing.
Can you assign them to variables and concat them?
Oh,
Yes, we should. Well, I mean, so the actual regex itself is an object, but
Yeah.
the definition of it could be from like a string or something. So you would have to create a new regex based on them. But
Oh, I see.
use the constructor.
concat it. I never thought about that. Okay. Yes.
What kind of like performance issues do you consider with using projections over like native replace or something like that?
That's something that I don't know much about. I need to look into it. I imagine this has, I want to say more of a performance hit. Does anybody know if that's right?
It does have more performance, but dot replace is so limited.
Yeah, it's really basic,
Yeah,
right? So,
like, just that's what makes regex more of a performant hit. I think it would perform the same if the regex is simple. At least the
Yeah.
output didn't.
true. Yeah, I haven't looked into the performance of it. Luckily, I don't have to deal with that.
yeah, I don't think one regex is easier.
It is easier, right?
Yeah,
Yes.
That replaces regex.
I don't know if it does use it, but I didn't know if it's, you do a basic regex that matches replace, it's like almost the same performance. So
Right.
probably.
Yeah.
I know that the VA team, if you follow their blog, they often, when they do new conversions, they've made considerable improvements to the performance of Regex. That's something they spend a lot of time focusing on in recent review.
Cool. All right, guys. Thanks for coming out.
Great.